Hello and welcome to the tutorial video for Acadec Math Focus Quizzes 28 through 29. This will be the last video, and I will also be giving this lesson in person. Whatever tomorrow is on the 20th. And we'll be doing a lot of reviewing in person over the next several months. So that's exciting, isn't it? I know you'll love math. This is where the real calculus stuff starts. Really, the past two quizzes were where it kind of started. But some of these concepts, really, this is going to be one big concept for both of these quizzes. Even if it doesn't make sense to you, I'm going to very heavily emphasize the part that you need to memorize anyway. And if you're scared by it because it doesn't make any sense, you will simply have to buckle up because you just need to be able to use it. It might make sense, especially to those of you that are juniors or seniors. It might make a lot of sense, especially if you've taken physics. But just bear with it and do your best with it. All right. This is basically what I just said. You're welcome to pause and read. Okay, so what we're going to be finding here are derivatives. A derivative is an equation that you derive from another equation that allows you to find the slope of any tangent line on that equation. So I'm going to draw a parabola to kind of try to illustrate what I just said, more than just abstract speaking. So here's a parabola, right? More or less. Now, a tangent line is a line, remember the circles we had tangent lines? A tangent line is a line that only touches another line at one point. And at that point, it is perpendicular to that line. So a tangent line on this graph might look like this. Bonk, it only touches it right at x equals 4, or x equals 2, y equals 4. Or like this, bonk, or like this, bonk. And all of these lines have different slopes. When we find the derivative, we can use it to very simply find the slope of any of these lines. And you'll see that in a second. But that is what a derivative is. The way you write a derivative, so if your graph is y equals x squared, your derivative would be y prime equals whatever the derivative of this is, which we'll find in a minute. Or if you write it as f of x equals x squared, then f prime of x equals whatever the derivative of x squared is. For the most part, at least as far as y'all are concerned, derivatives follow a very simple pattern. And you don't have to learn the more complicated patterns for academic math, which is lovely, because that would be way too much. This is how you find a derivative. Before you get scared by it, this is how you find any derivative. There are rules that come out of this. If you just do it a bunch of times to start to notice things, that's what one of these rules are. The only rule you need to memorize is very simple. I am only going to show you a couple examples with this to show you that it exists, that I'm not just making up these rules. There's a reason they exist. There's a reason this exists. And there's a reason the thing that makes this exist exists. It's just proofs on proofs on proofs that I'm not going to show you, but I will show you a little bit of this so I can at least say that I tried to prove it to you. This line is y equals 5x. We can see that any tangent line here is just going to line up perfectly with the line. There's no other way to do a tangent line. There's no curved surface to bonk off of. So anywhere on here, the slope of a tangent line is going to be 5. Why is my phone not on silent? My bad. Move it over here. So let's plug in this f of x into here. I'm going to draw this guy. We're going to do it all over here. For reasons you will soon see. I don't need to line that long, actually. Let's do that. So f of x equals 5x. So f of x plus h is 5 times x plus h in parentheses minus 5x, which is just the f of x. The second part is always just whatever the equation is, all over h. And I didn't write the limit assume that it's there. It's a little blurb. We are finding what this is as h approaches 0. So we need to simplify all this first. This top part will become 5x plus 5h minus 5x all over h. This 5x and minus 5x are going to cancel out. And these h's are going to cancel out because it's being divided out. So all we're left with is y prime, we found the derivative, equals 5. And at any x value on this graph, the slope of the tangent line, or the instantaneous rate of change of the graph, is 5 for all time forever. And this equation just gives us that in a very concrete way. Now let's look at this one. This has a changing tangent slope, right? A changing instantaneous rate of change. The tangent line is technically the slope right at that point that it touches, but only right there. And the slope is always changing. So let's try to find that. We're going to plug in this x squared into this. Rather, we're going to replace these f of x's with this. So we're going to get x plus h squared. We got to plug that in parentheses. We're going to have to FOIL this and do all that stuff. Minus f of x, which is x squared, all over h. So we need to FOIL this, and that's going to give us something in a second. Just going to rewrite it all out anyways. So x times x plus x times h, x squared plus xh plus another xh plus h squared minus x squared all over h. Now we cancel and we simplify. This x squared and this minus x squared are going to go away. That's pretty much always going to happen. You don't actually have to use this until you go take calculus, but it can help. Like, you can just plug stuff into this and it'll always give you the derivative. Certain things are just way harder to plug into this than they are to just know the rules for. And the rule is really easy, I promise. Now we're combine more stuff. This h is going to divide out of this, and this, and go away. We could have combined those first, and maybe that would be simpler, but whatever. And we're left with just two x's added together, so 2x plus h. But it's the limit as h approaches 0. So that h is just going to be 0. So we're not even going to write it down. It's a left over h. As long as they are not dividing into stuff, they just go away. You don't care about them. So our derivative is y prime, or f prime of x, equals 2x. So what we can do with this is the key to finding the slopes of the tangent lines. Let's plug in 1. We plug in 1 to this, we get 2. So that means the slope at x equals 1 of this function, y equals x squared, or the slope of the tangent line right there, is 2. And if I drew better, that would look correct. It kind of looks correct anyways. It should cross like right there. But that slope is 2. If we plug in 2, this is going to be steeper, right? It's getting steeper and steeper and steeper as we go. So let's plug in 2. We're going to get 4. And if we draw a line across this point, the slope will be 4. Like if I took a ruler and perfectly lined it up, it would look like a line with the slope of 4. If we plug in the negative values, we can plug in -1, we get -2, which again looks about right. And this one would give us -4, which again looks about right. If we plug in 0, we will get 0. And there's anytime there is a hump in the equation like that, a maximum or a minimum, the derivative will be 0. And that's very, very useful in calculus. But to us, it's not terribly useful. They will expect you to know it, though, and you'll see that at the end. Now, we don't have to do all this. I just showed you it so that I can say I taught them the real thing. You just need to know the power rule. The power rule is y equals x to the n. To get the derivative of this, y prime, we take that exponent and we put it in front as the coefficient of x. So nx. And then in the exponent, we subtract 1 from n. So we get this. And if we look, that's what we did here. When we take x squared like that, so x to the 2 instead of x to the n, the derivative is, we take that 2, put it in front, 2x, and in the exponent, we take away 1 from the 2, which is just going to leave 1, so we don't have to write it, which is exactly what we got, right? In this one, we start with y equals 5x, and we are following the same rule, even if maybe it doesn't look like it. We are taking that exponent, which is 1, putting it as the coefficient, and subtracting 1 from it, which gives us 5 times that 1 that we moved, times x to the 0. Anything raised to the 0 is just 1, so we're just left with 5. Or 1 times 5 times 1, but everything just got canceled out. If you had the equation, it's getting kind of messy here. Pause, take notes, I don't know, I'm about to erase it. Bonk. If you had y equals x, the derivative of this is 1. So if you have an x anywhere and you are asked to derive it and it's just alone, it's going to be 1 because you're going to actually get y prime equals 1 times x to the 0, which just simplifies to 1. All right. If none of that made very much sense, we're going to practice it some and it will become apparent how easy this is to use. We're going to find the derivatives of all of these things, and then we're going to find the slope of those, the instantaneous rate of change I should have wrote, but whatever, of all those functions at x equals 2, or the slope of the tangent lines at x equals 2. So we'll do this here, and then we're using power rule. So you apply the power rule to anywhere there is a lone x. So in this case, this x, we already know that when it's just an x, it's pretty much just going to become 1. So we're going to be left with 2, or y prime equals 2. And any constants that don't have an x attached, they just go to the abyss when you take the derivative. They do not exist. They require an x to survive the derivative process. So the final answer to this is just y prime equals 2, which makes sense. This is just a line with a slope of 2. So any tangent line that we draw on a line is just going to have the same slope as the line. So it's always going to be 2. No matter what x we try to plug into this, it's not going to change anything. Now let's look at this one. We have x squared plus 8. We already know that 8's going to go away. The x squared is going to turn into, we take the 2, put it in front, 2x, and then we subtract 1 from 2 in the exponent, which just leaves us with 1. So y prime equals 2x. You'll notice that's the same that we got for this, even though this has a plus 8. That 8 just goes away. And those two graphs look like this and this. So at every x value, say if we go to x equals 1, they're going to have the same slope right there, regardless of how high up they are. They're going to have the same slope of a tangent line, instant radius. They're going to have the same stuff. So just adding on a constant doesn't actually change the rate of change of anything. It just changes its location. If it was right to left, it would change things, but that's not what adding a constant does to an equation. Now let's do this one. This has a coefficient attached to it already. When that is the case, you multiply what you've moved to the front and the existing coefficient together. So what we will get is we take that 2, put it in front, multiply it times that 7, we get 14x plus, and then this one's just going to become 1, 2. And that 5 goes to the abyss. So our equation for the derivative of this is this. And you'll also notice that we are always going down 1 degree. So we start at a quadratic here, we end up linear. We start at a quadratic here, we end up linear. We start at a linear here, we end up with just a value. We don't even have an x involved. This one, we're going to end up with a quadratic. The derivative of this, we take that 3, put it in front, 12x. We take 1 away from the 3, so this remains squared, goes down 1 degree, plus, take that 2, put it in front, 4x, and this stays 1, minus 5. And that 7 goes into oblivion. So our derivative equation here is that. And now let's find the actual slopes of all these functions at x equals 2. So we just plug in 2 to the derivative formula. That's how you get the slopes. So this one's still just going to be 2. This one will be 4, plugging in 2 there. This one will be 28 plus 2, 30. And this one will be really big. But I plugged it in earlier. It's 51. You're welcome to plug it in yourself. If none of that made sense, if you do not understand what I'm talking about with the instantaneous rate of change, the slopes, blah, 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 memorize the power rule. That's what you really need to know. That's what your actual tool that you're going to use. There are some other things on the test that look like this, or something kind of like this. Don't be freaked out by this. There's some exponent rules that exist that will always let you get it into a form that you can use the power rule on it. So right here, the power rule doesn't actually change. We move the -3 to the front, and then we subtract 1 from the -3 to get -4. So it's not really going down in degree. It kind of is. You just have to keep in mind that it is n-1. It wouldn't become -2. You're not just getting closer to 0. You're going down. So that's the answer to that one. This one, it might look like we just moved the 3 to the front and leave the 2 there, but that is not the case. When something is under 1, you have to use a different rule. You can't use power rule. But we can get this to look like this. Whenever you have something to a negative exponent, that's the same as writing it to the positive exponent under 1. So this is the exact same as this. So we can rewrite it as that, and we would end up with the exact same derivative. Should write y prime for each of these. Same thing for these. So we want this to get on top. We can just look at this one, though. And we will do the same thing. We move that -1/3 out front, x, and then we subtract 1 from -1/3, and we will get -4/3. So that is your derivative, your answer. For this one, I'm going to pretend that this is a negative down here. If you have something on the bottom and it's also negative, you're going to flip it to the top, and it will negate it again, and it will cancel out. So 1 over x to the -1/3 is the same as saying x to the +1/3. A lot of jumbly jumbo there, but I just want to show you taking the derivative of x to the +1/3. Just keep in mind that you do have to get it into the exponent spot. If it's negative or positive, it doesn't matter, but you cannot leave it under 1. You will not get the right answer. Anyways, so we do this. We're going to take the derivative of this, and that is +1/3 x to the -2/3. Because we subtracted 1, which is 3/3, from 1/3. All right, and again, if this is very confusing and you're watching it on the 19th, I will go over this in class, and you're welcome to ask questions. I can't promise that that will terribly clarify it, but don't let yourself get too freaked out. Just get used to the process of using the power rule. A couple more examples. We cannot do the power rule on this. We can't really take any kind of derivative from this. So we need to FOIL it out before we can use the power rule on it. So we're going to go x squared plus 3x minus 5x. Those are going to combine to -2x, or minus 2x, minus 15. And then we can use our power rule on it. So this is our f of x, our f prime of x, or y prime. Write it both ways because you'll see it both ways. Equals 2x, taking the power rule from that, minus 2. And that's it. That is the derivative of this. But you have to FOIL it first to use the one rule that they've given us. These are just more of those previous ones, but we need to rewrite this as x to the -4th plus x to the -3rd, and then we can use power rule like normal. And that's going to equal -4, pull that down, x to the -5th, because we're subtracting another from the -4, plus, minus, but plus -3 is fine, plus -3x to the -4th. And they might give you answer choices where they put that x back down on the bottom, and that would look like -4 over x to the 5th plus -3 over x to the 4th. That's just another rearranging. You're taking those negatives and put them back on the bottom. These are the same answer. Cool. that's it for Power Rule. That's the whole first quiz. There's a little bit more nuance to it than that. There's a couple questions that I'm going to tell y'all to just ignore because they are not on this year's math resource and or they don't have a right answer. But that's just my gift to you. Now we're going to look at actually using those slopes that we can find. So we know we can find the slope of the tangent line, but can we find the actual equation? The answer is yes. So point-slope form is something that you learned in geometry or are learning in geometry. It's just another way of writing a linear equation. So normally we would use y equals mx plus b. Not that easy to get this from some other, like a quadratic equation. We need to be able to use this. And we can find a point on the graph very easily. We'll probably be given an x, and we can plug that x into the original equation, not the derivative, to find a y value at the same point. And then we can get the slope at that x value by using the derivative. So let's go do that. Right now, we're not going to find the whole equation. We're just going to find the slope of the tangent line of this at x equals 1. And the way you do that is you just take the derivative and you plug in the x value, just like we did in the beginning. So the derivative of this will be 3 times that 6, 18x squared, minus 8x, and then that 8 goes away. So this is the whole derivative. Now we're going to plug in 1, and that will give us the slope at x equals 1 of this equation. This is like a special key to find the slopes, the many infinite slopes of this equation. So we plug in 1, we get 18 minus 8 equals 10. So that is your answer. If they wanted the equation for the slope of the tangent line, that's just taking the derivative. That's what the last quiz was. And they might ask you to do that anyways. And then your answer choices would look like this. Now we're going to find the whole equation of the tangent line for this equation at x equals 2. So we need a point x, y, or you can rewrite that as x f of x, which is when you plug in x to that equation, it will give you the y, and we need m, and that's all we need. And we already have an x, and we know how to find our m. So first, let's find the derivative, which is 4x plus 3. Not too complicated. We're going to plug in that 2 to find the slope at this point. So we will get 11. M is, well, this is what we need. Let's write them down here. So our point is going to be 2 something. Our m, we now know, is 11 because we got our derivative equation. This is f prime of x. And we plugged in 2 to get 11. Now we need to plug that 2 into the original equation to get the other coordinate of this point, this ordered pair. So we plug in 2 here. We're going to get 2 times 4 is 8 plus 6 minus 2, which is 12. 2, 12. So our whole equation is going to be y minus 12, which is our y1, equals 11, which is our m, times x minus x1, which is 2. This is the equation. Now, they might not give it to you looking like this. They might rearrange it into y equals mx plus b. They might rearrange it all the way back to standard form. And you have to be able to somehow figure out which of those is the same as this by converting. So to get to y equals mx plus b, we just distribute and simplify. So that 11 will go across to there. We'll get y minus 12 equals 11x minus 22. Then we got to move the 12 over here, plus 12 on both sides, y equals 11x minus 10. So this is the same equation as that in a different form. And then standard form, they'll probably give you the answer choices in standard form, and it's a lot easier to go from standard form to point slope. So I would do that with the answer choices and see which one matched. We'll find the slope of the tangent line of this at 224. This is just to distract you. All we really need is this and to find the derivative, because all it wants is the slope. So the derivative, we're going to move that 3 down there. We're going to get 12x squared minus, oh, nothing. That's it. That's the derivative. So we plug in 2, we get 12 times x squared. So the answer is 48. If it did want us to find the whole equation at this point, we would take that slope and we would use it to construct y minus 24, because they already gave us the point, equals 48 times x minus 2, because we have that other point already. So it's not really even harder, especially if they already gave you the y value. I believe this is the last one. For the in-person lesson, I think I'm going to do a couple more complicated ones, maybe some symbolic stuff. At the very least, I will go over them with y'all after the test. Some of them are just going to be doozies. Focus on the ones that you can do. This one is asking, at what point is the tangent line horizontal for this equation? So I hope, well, it's been a while. You'll remember that I said that right here, the tangent line is horizontal. That is where the derivative equals 0. So our derivative would be 2x. We set that equal to 0. We solve, we get x equals 0. That makes sense. That's where that is horizontal. There's nowhere the tangent line will be horizontal here, but any type of graph that has little humps, no matter the number of them, it's going to have a whole bunch of places where the tangent line is horizontal. And at all of those places, the derivative will equal 0. Boom, boom. Okay. So we need to find the derivative, set it equal to 0, and then that x value is part of our answer. We need both the x and the y, though. That's what they want. So our derivative is negative 14x plus 2, based on just using power rule. We're going to set this equal to 0 to find where the tangent line is horizontal. It's only going to be in one place because this is linear. And that makes sense. This is a parabola. It's only going to have one hump. We solve, we get negative 14x equals negative 2. X equals negative 2 over negative 14. Why did I write it like that? Whatever. X equals 1/7. So then we plug that back into here, because that is only one part of our final equation. And I'm going to do that in the calculator, which actually already has this graphed, so spoiler alert. Negative 7 times 1/7 squared plus 2 times 1/7 equals 1/7. And I actually graphed this earlier, and that point is 1/7, 1/7. So this would be your answer. If you have any questions on this, again, I'm going to do the whole lesson again tomorrow, or if you're watching this on Friday, if you're watching this in the future, I gave this lesson at some point. Besides that, good luck.